Good morning, grade 9 students. Our lesson today is about trigonometry in a right triangle. What does a word trigonometry mean? In Greek, trigono means triangle, metry means measure. The meaning is just the measure of all the things possible in a triangle, three sides and three angles. Trigonometry only deals with one kind of triangles, which is right angled triangle. This triangle is right angled at A or at vertex A, so one angle is known and two angles still remain. B and C are two complementary acute angles. The sum of two complementary acute angles is 90 degrees. BC is the hypotenuse. But how do these kinds of triangle help us in real life? Let's say I want to know the height of this tree. So the better way is by using trigonometry. Let us resume. The distance is known to us because it's easy to find the length in the ground than finding it vertically. And we can find the approximate measure of this angle. If this distance is known and this angle is known, then the height can be easily found out. But how? This is precisely what we will try to understand in trigonometry. Let's go back to the right triangle. Right triangle has a 90-degree angle. So this triangle is right angle at A. While B and C are acute complementary angles. In right triangle, the side facing 90 degrees is called the hypotenuse. Side BC is the hypotenuse of triangle ABC. It's the longest side in this triangle. Now, sides adjacent to an angle. Every angle is included between two sides. Angle ABC, which is red. Angle ABC is included between two sides, BC, which is the hypotenuse, and AB, which is the side adjacent to this angle. So side AB is adjacent to angle ABC. And the angle ACB, which is colored in blue, it's included between two sides, which is BC, the hypotenuse, and AC, which is the side adjacent to angle ACB. Now, in this right triangle, which is right angled at A and BC is the hypotenuse, we have the acute angles ABC and ACB. We have to mention here the sides opposite to an angle. It's the side that's facing the angle. Example, side AC is facing the acute angle ABC. It's the side opposite to angle ABC. And side AB is facing the acute angle ACB. It's the side opposite for this angle. So, side AB is the side facing angle ACB, and side AC is facing the angle ABC. Now you all know what do we mean by side adjacent and side opposite to an angle. Let us see the formulas of the three trigonometric functions. Consider the right triangle ABC right angled at A. BC is the hypotenuse. ACB and ABC are acute angle. Let the angle ACB called alpha. Alpha is a Greek letter utilized to express the measure of the angle in degree. AC is the side adjacent to angle alpha, and side AB is the side opposite to angle alpha. The three trigonometric ratios or function are sine, cosine, and tangent. Let's start by the formula sine. Sine function, its abbreviation as SIN. Sine alpha is equal to the length of the hypotenuse of the opposite side, over the length of the hypotenuse, which is side AB over side BC. Cosine function, it's written as COS. Cosine alpha is equal to the length of the adjacent side to alpha over the length of the hypotenuse, which is AC over BC, as cosine alpha equal to the adjacent side, which is AC, over hypotenuse, which is BC. But for any acute angle alpha, we have to know that sine alpha is between 0 and 1, and also cosine alpha is between 0 and 1. The third important function is the tangent function. It's written as TAN, tan alpha, which is equal to the ratio of the length of the opposite side to alpha over the length of the side adjacent to alpha. It's the length of the opposite side to alpha AB over the length of the adjacent side to alpha, which is AC. Now, let's try dividing sine alpha by cosine alpha. Sine alpha, what does sine alpha equal? It's equal to opposite over hypotenuse, and cosine alpha is equal to adjacent by hypotenuse. By calculating this ratio, opposite over hypotenuse times hypotenuse over adjacent, we can reduce hypotenuse from the numerator and the denominator, so which gives us opposite over adjacent. Does this look familiar to us? Yes, the value opposite over adjacent we see here on tangent function. So we just proved one of the important trigonometric function, which is sine alpha over cosine alpha equals to tangent alpha. Thank you, my students. Stay safe.